Hello, welcome to online class. This is me, Harris. Now we are discussing the chapter Redox reaction. Redox reaction, chapter number 8 of your class 11th in your NCERT textbook. Redox reaction. Okay. So comparatively, it's a simpler chapter. Okay. So moving to the theory first. You know what you mean by, or you know what is a redox reaction. A redox reaction, a reaction in which oxidation and reduction takes place simultaneously, right? A reaction in which oxidation and reduction takes place simultaneously. What do you mean by oxidation? The phenomenon of losing of electron, or there are a lot of definition for oxidation. What do you mean by reduction? Or gaining of electron, or have another definitions. Okay, so you're familiar with oxidation and reduction, right? So if a process have oxidation as well as reduction simultaneously, then a reaction have oxidation as well as reduction simultaneously, then the reaction is said to be a redox reaction. So a reaction in which both oxidation and reduction, takes place simultaneously. Okay, or a reaction where oxidation state of elements changed. If a reaction where the oxidation state of elements are changed, then the reaction is also said to be a redox reaction. Okay, so this is what we call as a redox reaction. So first of all, we have moved to the terms oxidation and reduction. This is simply the definition of your chapter, redox reaction. If there are chemical reaction where the oxidation and reduction takes place simultaneously, then the reaction is said to be a redox reaction. Okay, or simply, or in another way, if a reaction where the oxidation state of elements are changing, then the reaction can also said to be a redox reaction. First of all, I'm simply showing the definition of oxidation and reduction. Okay, there are three concepts. The first one is classical concept, and the second one is electronic concept, and the third one is oxidation number concept. There are three concepts. So first of all, definition. The first definition is for your oxidation, the process oxidation. Okay, listen. Oxidation in a classical way, a chemical reaction where oxidation takes place means if oxygen is added to some elements, or according to me, or considering me, if I undergoes oxidation, how it means if oxygen is added to me, or electronegative element is added to me, or hydrogen is removed from me, okay, or electropositive element is removed from me, like that. Okay, so oxidation, the definition, first one, on the basis of addition. So if you are adding oxygen to a particular species, then there happens oxidation. So addition of oxygen. If your oxygen is added to some species, then the species undergoes oxidation. Ready? Okay. Or there is no need of adding oxygen. Okay, or we have another possibility, we can add electronegative element. So either we can add oxygen or we can add a electronegative element, Okay, I'll give you an example. Listen, sodium. Okay, if oxygen is added to sodium, what happens? It become, let it be 4Na, okay? It become 2Na2, sodium oxide. Ready? You're familiar with the oxidation state. I'll discuss it in a detailed way. I think you know something about oxidation state. Okay, sodium having an oxidation state of 0, oxygen having an oxidation state of 0, and sodium here having an oxidation state of +1, and oxygen having an oxidation state of -2. What happens? Oxidation and reduction, which means a redox reaction. What happens to sodium? What happens to sodium? To sodium, oxygen is added, right? So from 0, sodium become +1. So what happens? Sodium loses 1 electron, which means sodium undergoes oxidation. So if sodium metal is added with oxygen, or sodium gain oxygen, it undergoes oxidation. So if a species is added with the oxygen, then the process is oxidation. So here the process is oxidation with respect to sodium. With respect to sodium, the oxygen is added to sodium. What happens to sodium? Sodium undergoes oxidation. Okay, like that. There is no need of oxygen itself. If I have sodium, I'm adding fluorine to it. Okay, what happens? The forms sodium fluoride, right? Sodium fluoride. What about the oxidation state of sodium? 0 to +1. Sodium once again from 0 to +1. What happens? Loss of 1 electron, which means oxidation. Ready? So what exactly happens here? Fluorine, the most electronegative element, or simply an electronegative element, is added to the sodium. So sodium undergoes what? Oxidation. Sodium undergoes oxidation. So that's all about the definition. First two definition. Addition of so oxidation means either the addition of oxygen or the addition of electronegative element. The process will be oxidation. Or with respect to a species, if oxygen is added or electronegative element is added, the process is oxidation. Moving to the next. Removal. The definition of oxidation in terms of removal concept. If you are able to remove something from some species, then for oxidation, in order to happen oxidation, you should remove hydrogen. So removal of hydrogen, the process known as oxidation. Okay, or there is no need of it is not compulsory that the hydrogen should remove. We can remove electropositive element also. Okay, so removal of electropositive element, the process is also oxidation. Removal of electropositive element is also oxidation. So on the basis of removal sense, you should remove hydrogen or you should remove electropositive element. I'll give you an example. Listen carefully. Listen. This is all a simple section, okay? If I have hydrogen chloride, HCl, okay, I'm simply removing hydrogen from it. So hydrogen is removed from hydrogen chloride. Hydrogen removed. So chlorine will be free like this. Okay. So with respect to, from chlorine, hydrogen is removed, and the chlorine from -1 to become 0. What happens to chlorine? -1 to become 0. What happens? Oxidation. So chlorine undergoes oxidation. Chlorine undergoes oxidation by the removal of hydrogen, right? -1 to 0 means electron is lost. So chlorine undergoes oxidation. Ready? So from a species, the species chlorine here, if hydrogen is removed, the process oxidation. Okay, like that, we have potassium chloride. If potassium is removed, then it become 2K, and the chlorine become free right now. Okay, so what happens? -1 to 0. -1 to 0. So if electropositive element, here the electropositive element, what it is? Potassium. Potassium is removed, then the chlorine once again undergoes oxidation. I think these examples and the definition is okay right now. Okay. So these all are said to be a classical concept of oxidation. Classical concept. This addition removal concept is known as classical concept. Classical concept. So on the basis of classical concept, what do you mean by oxidation? Oxidation is either the addition of oxygen or the addition of electronegative element. Okay. On the basis of removal essence, classical definition will be for oxidation, it will be the removal of hydrogen or the removal of electropositive element. Okay. Moving to the next concept. The next concept is electronic concept. Electronic concept. On the basis of electronic concept, if a species lost electron, it undergoes oxidation. If a species lost electron, it undergoes oxidation. Listen, have zinc, and zinc losses 2 electron, where electron and proton ratio will be changed. 2 electrons lost, which means 2 proton will be excess, so having a 2 positive charge, where the lost electron will be like this, or it can show up like this, plus 2 electron, or here minus 2 electron, whatever it may be. This is a process where zinc simply loses 2 electron. So the process is oxidation. Okay. Moving to the next. This concept is known as the loss of electron. The concept is known as electronic concept or electronic definition of oxidation. Or simply electronic concept. Okay. The next, what it is? Increase in oxidation state. Increase in oxidation state. That is said to be oxidation number concept or oxidation state concept. If oxidation state of some species is increased, then the process will be oxidation. Okay, I'll give you an example. Listen. If I have chromium is in +3 oxidation state, if it turns to +6, what happens? The oxidation state from +3 to +6, the oxidation state become increased, or oxidation state increased. Increase means become more and more positive, right? So the process will be oxidation. Okay, and this concept, that is said to be oxidation state or oxidation number concept. Oxidation number concept. This concept is known as oxidation number concept. Okay, so these all are the definition of oxidation. So what do you mean by redox reaction that I discussed? Now the definitions of redox reaction. There are 3 concepts: classical concept, electronic concept, and oxidation number concept, and all they for oxidation with an example. Okay, exactly in the very same idea. If oxidation and reduction are inverse process. Okay, if I'm moving from here to the, if this is oxidation, then the return will be reduction. Okay, with respect to sodium, if this process is oxidation, with respect to sodium, if oxygen is added to here, then it will be oxidation. So from here to the, or the reverse of this reaction with respect to sodium, it will be reduction. Okay, so with respect to a species, if the forward reaction is oxidation, then the backward reaction will be reduction. So now you are familiar with the definition of oxidation. So you simply reverse the whole, you obtain the definition of reduction. Okay, let's check. Okay, now we can discuss the definition of reduction. Definition of reduction. And there are 3 concepts again. Classical concept. The classical concept on the basis of addition sense. So I told you that oxidation and reduction are inverse. Okay, in oxidation, the addition of oxygen or electronegative element. Ready? Or the removal of hydrogen or electronegative element. So what removed, that should be added here. For oxidation, what do you remove? That you have to add here for reduction. Okay, so addition of we removed hydrogen there. So now we wanna add hydrogen here. So addition of what? Hydrogen. Addition of hydrogen is oxidation. Or then we can have a choice to remove electropositive element for in the case of oxidation. Now it will be the addition of electropositive element. Okay, exactly opposite. Okay, addition of electropositive element. Okay, I'll give you an example. addition of hydrogen, right? So H2 plus F2 gives to HF. This is a reaction. Agreed. So with respect to fluorine, hydrogen is added. Then what happens to fluorine? Fluorine, the oxidation state becomes 0 to -1. Fluorine gains 1 electron. So fluorine undergoes reduction if hydrogen is added to fluorine. So by the addition of hydrogen, a species which undergoes reduction, or the addition of electropositive element, like, okay, so I'm have magnesium and just added to chlorine. Okay, what happens? It becomes MgCl2. Magnesium is an electropositive element. It is simply added to chlorine, right? So what happens to chlorine? Chlorine becomes 0 to -1. So what happens to chlorine? Chlorine undergoes reduction. So a species which undergoes reduction if electropositive element is added to it, like magnesium. Ready? Or you can take any example, okay? The next, removal. Removal of what we added in the previous case, that you have to remove here. എന്തായിരുന്നു add ചെയ്തിരുന്നത്? Oxygen, addition of oxygen. So you simply remove oxygen. So removal of oxygen, or removal of electronegative element. Either the removal of oxygen or the removal of electronegative element. Okay. So the removal of oxygen, I'll give you an example. Have mercuric oxide, HgO. On heating, it can lose oxygen. So oxygen is removed, right? So with respect to mercury, oxygen is removed, right? So if oxygen is removed, what happens to mercury? From +2 to it becomes 0. What happens? +2 to 0, the oxidation state decreases, or it gains 2 electron. So undergoes reduction. So if oxygen is removed from some body, that body undergoes reduction. There is no need of removal of oxygen. We can remove electronegative element also. So from MgF2, F2 is removed. What is fluorine? Fluorine is a good electronegative element. So fluorine is removed from here. So from +2 to your magnesium becomes 0. So what happens? Reduction. So exactly the counter of your oxidation. What do you add in the oxidation that you have to remove for reduction? What do you remove in the oxidation that you have to add in reduction? And this addition removal concept, once again, this is the classical idea. Classical concept, okay? So the next electronic concept. Though you lost electron, so now you have to gain electron. If somebody gain electrons, it undergoes reduction. Let we have 2Cl minus, and it gains, let we have chlorine, Cl2, it able to gain 2 electron, and it become 2Cl minus. Okay? Now, with respect to chlorine, the process reduction, because chlorine is able to gain 2 electron. So gain of electron is reduction. And this is the concept, what we called as electronic concept of reduction. Ready? Move to the next. Oxidation number concept, okay? So for oxidation, the oxidation number should be increased, become more and more positive. For reduction, the oxidation state should be decreased, which means the oxidation state become more and more negative, okay? So decrease in oxidation state, okay? Your oxidation state can be represented as OS, okay? OS is enough, okay? I'll write it in the next section, okay? OS, oxidation state or OS in a short form, right? Now decrease in oxidation number, and this is the oxidation state concept. Oxidation number concept. Oxidation number concept for the reduction. Right? If permanganate MnO4 minus is reduced to Mn2 plus, what happens? The oxidation state of manganese from +7 to, it turns from +7 to +2. The oxidation state is decreased or become more positive. more negative. More negative or less positive, both signs are same, or the oxidation state is decreased. So you can easily say that the process is reduction. So these all are the definition of reduction. Okay. So in the case of reduction, you are permitted to add hydrogen or add electronegative positive element, or you are permitted to remove oxygen or electronegative element, or you can in terms of electron, you should gain electron for reduction, or in terms of oxidation state, your oxidation state should be decreased. Okay. So I think you're okay with the definition of oxidation and reduction. Move into the next logic, oxidizing agent and reducing agent. Oxidizing agent and reducing agent. It's a very simple idea, which have something which is related with this all, oxidation and reduction. So oxidizing agent and reducing agent. These all are related with the oxidation and reduction. What do you mean by agent? So what do you mean by agent? Agent means somebody who are able to help. Okay. So I have an agent, which means that person is able to help me, like that. Oxidizing agent, which means a person who is able to help oxidation. Reducing agent, a person who is able to help reduction, like that. Okay. Okay. You can check or now we can discuss the topic oxidizing agent and reducing agent. Oxidizing agent and hello. Guys, now we can discuss the topic oxidizing agent and reducing agent. Let me deal with reducing agent first. Reducing agent or reductant. It is reducing agent or reductant. Okay. Reducing agent can be represented as Ra. So either reducing agent or reductant. Then what do you mean by reducing agent? I told you that agent is somebody who is able to help them. So reducing agent means something who is ready to help reduction. Ready to help reduction. So a species which ready to help reduction, or which helps for reduction, or which can help for reduction. Species which help for reduction. Wait. I have somebody which undergoes reduction. This is somebody where it undergoes reduction. This is a person and it should undergoes reduction. Reduction means what? Gain of electron. So this species should gain electron. Agreed. And what do you mean by a reducing agent? A species which helps for reduction. Now the species is here. This is a species which is a reducing agent. Reducing agent means a species which helps for reduction. So this species which can helps for reduction, or which means this species can help this one. How it is? This is gaining, or this species is gaining electron now. So this person can lose electron. This person can supply the electron which are required to gain by this one. Okay. So reduction means somebody have to gain electron. And how another person can help that species means by losing electron. If I want to gain some electron, how you can help me? By losing your electron. That's the concept. So this is a species which undergoes reduction, and there are somebody which can help for reduction, which is said to be reducing agent. How it help means it can lose electron through or via losing electron. So the reducing agent should lose electron. So the reducing agent should undergoes oxidation. The reducing agent should undergoes oxidation. Ready? So if I want to gain some electron, or I want to undergo reduction, how you people can help me? You can lose your electron and give it to me. So what happens to you? You undergoes reduction, moreover, you undergoes oxidation by losing electron, moreover, you help me. So a species which helps for reduction is the first way. And itself undergoes oxidation, right? And itself undergoes oxidation. So the species undergoes reduction, species which helps for reduction, but it undergoes oxidation. Okay, listen. How you can identify an oxidizing agent, reducing agent? Listen. Now have a process, a permanganate in presence of hydrogen peroxide. Your potassium permanganate in presence of hydrogen peroxide become Mn2+. Mn2+ means a manganese ion. So what exactly happens here? The oxidation state of manganese in permanganate is +7, right? And now it become +2. So what is the process which takes place? Reduction. And the reduction process is helped by H2O2. So H2O2 is a reducing agent. Here the permanganate, here the manganese accept electrons, gain electron, and the necessary electron is given by H2O2. So H2O2 is a reducing agent. And this is the one way you can identify a reducing agent. How it is? A species which helps for reduction. So this is a process, reduction, and H2O2 is able to help that. Okay, so H2O2 become a reducing agent, or then another way means Zn plus Cu2 plus gives Zn2 plus Cu. Another way is a species which undergoes oxidation is also said to be reducing agent. So which species undergoes oxidation here? Zinc. So zinc undergoes oxidation here, and copper undergoes reduction. So the reduction of copper which is helped by zinc. So zinc is a reducing agent, or it can simply identify by, if zinc undergoes oxidation, then you can say that zinc is a reducing agent. So you can identify the reducing agent in two ways. Okay, either if anybody is able to help reduction, the reduction of permanganate is helped by H2O2. So H2O2 is a reducing agent. Or if anybody undergoes oxidation, zinc is undergoes oxidation. So zinc is a reducing agent. So these are the two sense that by which you can identify the reducing agent. Okay, and you know that a reducing agent should satisfy the definition of oxidation. Agreed? So reducing agent should satisfy the definition of oxidation. So a reducing agent should how I undergoes oxidation? If oxygen is added to me, or if electronegative element is added to me, it is already discussed, right? How I undergoes oxidation. If oxygen is added to me, or if electronegative element is added to me, if hydrogen is removed from me, electropositive element is removed from me, or if I lost electron, or if my oxidation number is decreased, then the whole indicates that I undergoes oxidation. Then what about me? Me is a reducing agent. So a reducing agent should satisfy, or the reducing agent should gain oxygen. If you added oxygen to me, in my side, what happens? I simply gained oxygen. So if I gained oxygen, I undergoes oxidation, and I am a reducing agent. So reducing agent should gain oxygen, or it should gain the very same definition that we discussed before. It should gain electronegative element, or it should lose. If hydrogen is removed from me, what happens to me? I undergoes oxidation. Oxidation, right? Or in my side, hydrogen is, I'm simply losing hydrogen. Hydrogen is lost. So what happens to me? The very same, oxidation. Then what about me? I'm a reducing agent. So loss of hydrogen, or the loss of electropositive element. You got the logic? Electropositive element. Or simply I wanna drop electrons. Okay, so loss of electrons. or my oxidation number, my oxidation number should increasing. The upward arrow indicates increase. Okay, increase in oxidation number. Is that okay? It is nothing but the definition of oxidation, right? So that's all about the reducing agent or reductant. What do you mean by reducing agent? Somebody who is able to help reduction by undergoes oxidation. So somebody means a species, a chemical species, which undergoes oxidation and helps for reduction. They're all said to be reducing agent, and the reducing agent should satisfy this all. Okay. So moving to the next. The next is about oxidizing agent. What about oxidizing agent? Listen. Oxidizing agent or oxidant. Oxidizing agent or oxidant. Fine. Exactly in the very same idea, or exactly in the very same manner. What do you mean by agent? Somebody helps. So somebody who is able to help oxidation is said to be oxidizing agent. So a species which help for oxidation. A species which helps for oxidation. A species which helps for oxidation. Ready? Wait. How somebody can help oxidation? How it helps oxidation? This is a process, or this is a person who undergoes oxidation. So this person should lose electron, right? He will, or he is able to lose electron, right? If I'm the person who undergoes oxidation, and you some guys are helps for me, and you people are said to be oxidizing agent. Ready? So I'm the person who undergoes oxidation. Then what I have to do? I'm simply dropping electrons. So I'm losing electron. Then what do you have to do? You're simply looking at that? No. What do you have to do? You simply gain that electron that I lost from me, right? So you should gain electron. In that way, you have to help me. So you peoples are able to help me. Help me means help oxidation. So you peoples are said to be oxidizing agent. Moreover, you peoples are gaining electron, right? So you peoples are undergoes reduction. So a species which helps for oxidation and itself undergoes in the very same type or in the very same style, in the very same trend, itself undergoes reduction. Okay, so this is a person who undergoes oxidation. He is simply leaving the electron or losing the electron. And now here is somebody who is said to be oxidizing agent. So he should gain that electron. Then only he can help the oxidation. So and that person is said to be oxidizing agent. So what happens to that person means he gains electrons. So what happens? He undergoes reduction. Okay, ready? I'll give you examples. Listen. If your Fe2 plus, which become Fe3 plus, what about the process? +2 to +3 oxidation state change. The process is oxidation, right? Okay. Now, a permanganate. Your ferrous ion is oxidized to ferric. Fe2 plus is said to be ferrous and Fe3 plus is said to be ferric. Now your ferrous is oxidized to ferric in presence of what? Permanganate. So permanganate is able to help the oxidation of Fe2 plus to Fe3 plus. So your permanganate, you can set it as, call it as oxidizing agent. So now, here I simply said that MnO4 minus for manganate ion is an oxidizing agent. How? It helps the oxidation process. Or in the very same style, Zn plus Cu2 plus gives the Zn2 plus Cu. Okay, I want to identify the oxidizing agent. So I'm simply looking to what? Which species undergoes reduction? So which species undergoes reduction? The species is copper. So copper undergoes reduction. So copper will be the oxidizing agent because it is able to help the zinc for oxidation. All right. I think you're okay. So what about the definition that you have to satisfy by oxidizing agent? Tell me. The oxidizing agent should satisfy the definition of reduction. Okay. For me, what are the different cases for reduction? Hydrogen is added to me, or in my side, I will be able to gain hydrogen. So gain hydrogen. So an oxidizing agent should gain hydrogen, or it should gain electropositive element. What about reduction from me? What I have to remove for reduction for me? You have to remove oxygen from me, right? Or in my side, I have to lose oxygen. So losing of oxygen undergoes reduction, which will be satisfied by oxidizing it. So loss of what? Loss of oxygen or loss of electronegative element. What about the electron? For me, what about the electron for reduction? I should gain electron. So for oxidizing agent, it should gain electron, or his oxidation state should decrease. So decrease in oxidation state. Downward arrow indicates that a decrease. Okay. So decrease in oxidation state. So I think you are okay with oxidation and reduction, right? Fine. Wait. Now we can simply predict which species or what about the tendency for oxidation and reduction, or a species which can undergo oxidation. Sorry. Now we can predict whether a species is a good oxidizing agent or a good reducing agent, or it can act as both. Look. Listen. So the next criteria, that is prediction of oxidizing and reducing agent based on oxidation state. Based on oxidation state. Listen, I have an element phosphorus, and the maximum positive oxidation state by which the phosphorus can attain is +5, and the minimum negative oxidation state by the which phosphorus can attain is -3. Okay. Wait. Now your phosphorus is in +5 oxidation state. Now your phosphorus is in a compound. Now your phosphorus is in +5 oxidation state. So it is clear that the phosphorus cannot further oxidize, right? Phosphorus is not able to oxidize further. Why? Because it is in the maximum oxidation state. It is not able to increase its oxidation state because it is in the maximum limit, right? So phosphorus is in the maximum limit. So it is not able to increase its oxidation state. So what can do? It have only one choice. That means it can decrease its oxidation state up to -3. So if a species is in the highest oxidation state, if a species is in in general sense, if a species is in a highest oxidation state, it will not undergo oxidation because that is a maximum. It is not able to increase its oxidation state furthermore, right? So that is a maximum. So it can readily decrease its oxidation state because it is in the top state. So it can simply reduce its oxidation state. So what about here? In the case of phosphorus, never oxidation, right? If phosphorus is in the highest oxidation state, it never oxidizes. Never oxidation. Then if a species which never undergoes oxidation, then it always undergoes reduction, right? So always reduction. If a species which undergoes reduction always, then it will be a good oxidizing agent, no doubt. It will be a good helper for oxidation. So it is a powerful or good what? Oxidizing agent. Good oxidizing agent. So in general, this is in the case of phosphorus. In general, a species, and this is how you can predict it, okay? A species is in a species. The first criteria, highest oxidation state. What it is? It is H, okay? Highest oxidation state. It will be a good oxidizing agent, no doubt. And this is a necessary explanation, okay? Now, come to here. if your phosphorus in a compound, your phosphorus is exists in a -3 oxidation state, which means the lowest limit. So the phosphorus is not able to decrease its oxidation state furthermore. So it is not able to decrease its oxidation state into -2, -1 like that, because this is the maximum or the limit. So it is not able to decrease its oxidation state. So if your something is not able to decrease its oxidation state, means that process will not take place. What do you mean by the process, or what do you think that the process of decrease in oxidation state? That is reduction. So it is not able to decrease its oxidation state, which means that it is not able to reduce, or it is not able to undergo reduction. So never reduction, because this is the most reduced state. It undergoes never reduction. It is not able to reduce, right? So if a species which never undergoes reduction, means in a redox reaction, it can always act as oxidize. If a species which never undergoes reduction, means if that species take part in a chemical reaction, that species can act as, or the species undergoes always oxidation. So always oxidation. If a species which always undergoes oxidation, means it will be a good helper of reduction, which means it will be a good reducing agent, right? It will be a good reducing agent. It will be a good reducing agent. Good reducing agent. So the second point, if a species is in the highest oxidation state, good oxidizing agent, the lowest oxidation state, it will be a good reducing agent. Good reducing agent. One more case is there. If a species is in an intermediate oxidation state, intermediate, in between lower and higher. So he has choice. He has choice, right? If it is in an intermediate OS, the species have choice. It can simply oxidize. It can simply increase its oxidation state. So it can simply oxidize, or it can undergo oxidation. So it can act as reducing agent if its oxidation state is increasing, because it is an intermediate, right? Or the next choice is it can reduce it. It can reduce it, okay? So it can undergo reduction also. So it can act as oxidizing agent. So what about the species in an intermediate oxidation state? It can undergo oxidation, so reducing agent. It can undergo reduction, so an oxidizing agent. So both, it can act as both, okay? So intermediate OS, if it is in a species is in a intermediate OS, so it can act as both OA and RA. Ready? Ready? Okay. I'll give you one example. This is how you have to choose something. Now we have sulfur, H2S. We have sulfur in SO2. We have sulfur in H2SO4. What about the case? The lower limit of sulfur is -2. So now your sulfur is in hydrogen sulfide, it is in -2. So it is a reducing agent, because it is the lowest oxidation state. If a species is in the lowest oxidation state, it is a good reducing agent. Here the sulfur is in +4. +4 is not the higher limit. It's intermediate. So both. It can act as both. Now we have +6. +6 is the maximum upper limit of your sulfur. So what happens? It's a good oxidizing agent. So for this kind of prediction, you have to know, or you are able to find oxidation state well. So let us discuss the criteria or the technique for finding oxidation state. Okay, so I think you're okay with the redox reaction, oxidation, reduction, reducing agent, oxidizing agent, and the prediction of oxidizing agent and reducing agent using oxidation state. So now we can discuss more and more about your oxidizing agent. Okay, look, before going to the guys, friends, before moving to the different rules for finding oxidation state of element, we can discuss the difference between oxidation state and valency. Oxidation state and valency. So oxidation state is the charge of each atom in a species. Charge of each atoms in a species. The charge may be positive or negative, like that. The species may be ion or molecule, whatever it may be. And we will discuss detailed about oxidation state. What about valency? Valency is the combining capacity. Combining capacity of element or atom. What about the combining capacity of an atom? That is said to be valency. And your oxidation state may be 0, negative, positive, or fraction. Because it is a charge which carried by a molecule, atom in a molecule, or a species, or an ion. Okay. What about valency? Valency may be 0 or positive integers, not fraction. 0 it may be 0 or a positive integer. Okay. Now, I am simply classifying the valency into two. Electrovalency. The first valency, that is electrovalency. Do you know about electrovalent bond? Your ionic bond. The ionic bond is said to be electrovalent bond. So how an ionic bond is formed? By the transfer of electron from a metal to non-metal. Agreed? Yeah. So electrovalent bond is nothing but it is ionic bond. And how ionic bond formed means by the transferring of electron from a metal donor to non-metal or receiver. Then how much electron is transferred from a donor to receiver? That is said to be electrovalency. So what do you mean by electrovalency? A number of electrons. Number of electrons transferred from metal to non-metal. From metal to non-metal. Number of electron transferred from metal to non-metal in an ionic bond. In an ionic bond. Wait. Have a molecule magnesium oxide. What happens? It is clear that 2 electron is transferred from magnesium to oxygen. So what is the electrovalency here? 2. What about the oxidation state in MgO? I think you know that the magnesium having an oxidation state of +2. Oxygen having -2. So the electrovalency of magnesium, that is 2, and the oxidation state of magnesium, that is +2. So it is clear that electrovalency always equal to oxidation state. Electrovalency of a metal or an element always equal to its oxidation state. Now we have another valency term. The valency term is said to be covalence. What it is? Covalency. Something related to the covalent bond, right? You know what is a covalent bond. And this electrovalency, the term related to the ionic bond. Now the covalency term which is related to the covalent bond. How a covalent bond is formed? By the let me form a covalent bond. I am the species, central atom, who is able to form covalent bond. So for the formation of covalent bond, I am simply share the electrons, right? Yeah. So how much electron is shared by me, that much bonds are formed near me, right? So simply covalency is the number of electrons shared or number of covalent bond around me. Yeah. So covalency is the number of electrons shared by an atom in covalent bond. Okay. Now let we have a methane molecule. How much electron is transferred or how many covalent bond around methane? Simply number of electron transferred there, that much bonds will be formed. How much covalent bond is there? 1, 2, 3, 4. 1, 2, 3, 4. So the covalency, number of covalent bonds, so simply number of electron transferred, that is 4. What about the oxidation state of carbon in methane? The oxidation state of carbon in methane, I think -4. Whatever it may be, the oxidation state is -4. Numerically, here the covalency, numerically the covalency 4 minus 4, the covalency equal to oxidation state. Fine. Wait, if I have ammonium ion, NH4, what about the oxidation state? What about the oxidation state? We will discuss the how we can find the oxidation state, and somebody of you may know that the oxidation state of nitrogen is -3. So nitrogen having an oxidation state -3. Okay, what about the covalency? For the covalency, let me draw the structure. Right? Yeah, like this. Positive entity. What about the number of covalent bonds? Covalent bond number 1, number 2, number 3, number 4. What about the covalency? Covalency is 4. Now the covalency 4, oxidation state 3. So it is clear that covalency not equal to oxidation state. So always electrovalency equal to oxidation state, but covalency may equal to oxidation state or may not be equal to oxidation state. So covalency may or may not be equal to oxidation state. Simply these are all the examples. Okay, fine. Ready? That's perfect. So now you know what about valency and oxidation state. Valency is the combining capacity, and have the possible values is 0 or the positive integers. But the covalency, oxidation state is the charge possessed by an atom in any species. The species may be molecular, ion, or anything. And electrovalency means the number of electrons transferred in an electrovalent bond. What about electrovalent bond? It is an ionic bond. So transferring is always from metal to non-metal. And your electrovalency always be equal to covalency. Ready? And what about, electrovalency always equal to oxidation state. What about covalency? The number of electrons shared for the formation of a covalent bond. Okay. Electrovalency may be equal to oxidation state, or it may not be equal to oxidation state. That's all. Guys, now we can discuss the rules for finding oxidation state, OS. The first rule, if an element which exists in its atomic state, its oxidation state will be 0, because no electron lost or gained by that element. If an element element have two states, atomic state and ionic state. If I have zinc is in 0 state, it is said to be atomic state of zinc. If the zinc is in +2 state, it is a common oxidation state of zinc. And that +2 state is said to be ionic state, and 0 state is said to be atomic state. If an element which is in its atomic state, its oxidation state will be 0. Whatever be the atomicity, whether the element is monatomic, diatomic, tetratomic, pentatomic, like that, anything. So the first rule for an element in its atomic state, implies oxidation state is equal to 0. Oxidation state is equal to 0. Okay, oxidation state is equal to 0. I'll give you an example. I have atomic state of hydrogen, H2, atomic state of oxygen, O2, atomic state of nitrogen, N2, atomic state of sodium, Na, atomic state of calcium, Ca, atomic state of phosphorus, tetratomic, P4, atomic state of sulfur, S8, octatomic, where the charge of these all atoms is 0. Because they all are in atomic state. No electron lost or gained by that element. That you know, I think. Move to the second. And the second state of an element. For an element in its ionic state, then the OS will be the charge on that ion. If any element which exists in its ionic state, then what is the charge represented on the top of that ion? That will be the oxidation state. OS equal to charge on ion. I'll give an example. Listen. Have Ca2 plus. Cl minus, O2 minus, Zn2 plus. Okay, C4 plus, like that. What about the oxidation state? Here the oxidation state is a charge, plus 2. Oxidation state is a charge, minus 1. Oxidation state is a charge, minus 2. Oxidation state is a charge, plus 2. Oxidation state is a charge, plus 4. Like that. Okay.